Hey guys, this is Math 116, section 6.5, last section. This is loans and amortization. So amortization is a very fancy word that is something you're probably very familiar with. This is borrowing money and payment plans. So amortization is when you repay a loan by making payments of equal size. So this is what, if you go to the car dealership and you buy a new Fiat 500, they're going to amortize the loan because each payment is going to be the same size. And in the old days, you get a payment coupon. You'd actually get a little book that had the payments you'd have to make, and you'd have to sign it and include a check and put it in the post box. But now they don't do that. So anyway, so your payments in this case are including principal and interest. So here's an example question. Question number 3. A debt of $8,000 is to be amortized with 8 semi-annual payments if the interest is 12% compounded semi-annually. What is the size of each payment? So imagine you're borrowing $8,000. What are you going to buy with $8,000? A used motorcycle. That's fun. I like to buy toys with my debt in my fictional problems because I just think it's more interesting to buy something fun. So suppose we're spending $8,000 and we're going to do 8 semi-annual payments. So this is what this is saying. Where's my pen? So we're going to borrow $8,000 for our motorcycle, right? We're going to buy a very cheap Harley. I don't think you can actually buy a Harley for $8,000, but you're going to make 8 semi-annual payments. Semi-annual payments. So you have a little coupon book. Imagine if the Harley dealership gave you a coupon book that had 8 payments in it, 8 little payment coupons, and it's compounded 12% semi-annually. So here is the formula you need to know. It's right here. Come on, baby. Here's the amortization formula. So this is essentially the present value formula, but they've reversed it and solved the formula for R. So in theory, you could do this on your test. You could take the annuities formula and solve it for R, but you'll probably just want to write it down. Here it is. This is the main formula you're going to use for this whole section. So R, this is your payment. Every month you're making this much. This is the total amount. A, the N, is the amount of debt that you're borrowing. So that's the price that you settle on. I'm going to buy this motorcycle for $8,000. I is the interest rate per period, and N is the number of periods. So if you're paying, semi-monthly, semi-annually, you have 8 periods. So in this case, R is equal to $8,000. That's how much we borrowed. N is equal to 8 because we have 8 periods. So imagine your little book has 8 little coupons in it, payment coupons. I is the interest rate per period. So this is 12% compounded semi-annually. So it's 2 times per year. So it's divided by 2. And that equals 0.06. So now we're going to use the formula. Sorry, I said R here. What is happening? That's A to the N. A to the N. Some of you were thinking, what is she doing? I don't know. Okay. R is equal to A to the N. So 8,000 times, big formula, 0.06. This is I on the top. It is I. Divided by 1 minus 1.06 raised to the negative 8. And again, that's I, and that is N, so negative N. This is all equal to $8,000 times this whole piece equals 0.1610, so this equals 1288.28. So every 6 months you're paying $12.88 for your motorcycle or whatever. So that's the payment that you are making every 6 months. So I'm just going to quickly reread the question, give you a sense for that. A debt of $8,000 is to be amortized with 8 semi-annual payments if the interest is 12%. What is the size of each payment? The answer is 1288.28 every 6 months. Is that a good deal? I don't know. How badly do you want that thing you just bought for $8,000? Question number 17. A man buys a house for $350,000. Okay, kind of reasonable. He makes a $150,000 down payment and amortizes, so he, takes a loan out for the rest, with semi-annual payments, so he's paying every 6 months, which is a little rough, but okay, for 10 years. So the interest rate on the debt is 12% compounded semi-annually. So first thing I'm noticing is he made a 42% down payment. Wow, good for him. He should get a lower interest rate for that, but he's only taking out a 10-year mortgage. So anyway, as a bit of an aside, I thought, what kind of house can you buy for $350,000? Well, if you're in Detroit, you can buy this house. It is a 6-bedroom, 3-bath, 3 full baths, 2 half baths. You get 4,800 square feet in this lovely house in Detroit. Isn't that pretty? Okay, but suppose you didn't want to live in Detroit. Suppose you wanted to live in Manhattan. What could you buy for $350,000? You can buy this little place. Just on the market, you guys. A 1-bedroom, 2 full baths for 612 square feet. 612 square feet. That's not very big, anyway, for a mere $350. So you got some choices. Back to our problem. A man buys a house for $350, either a 6-bedroom house in Detroit or a 650 square foot house in Manhattan. Here is the formula. Actually, here's what we're trying to do. Find the size of each payment, the total amount paid over the life of the loan, and the total interest paid. So for the size of the payment, this is part A of this question, we are going to use this same formula. This formula is your friend for this whole section. So we're going to start here, part A. So we need to know how much is the debt. This is going to be how much of the, how much debt is he taking out? Well, that's going to be $350,000 minus his down payment. So the debt that he's taking out is $200,000. Okay, that's not unreasonable for a house debt. N, that's the number of payments. Number of payments is equal to 10 years times 2 times per year. He's paying every 6 months, which is a little unusual, but I guess he made a deal with the bank. Semi-annual payments. So he's making a total of 20 payments, and his interest rate is 12% divided by 2, because it's semi-annual, right? Times per year is equal to 0.06. So according to this formula, we are going to do, moving this onto a different page, we have R, the size of each payment is $200,000. That's A to the N, that's the total amount that he took out. And then we have the interest rate, 0.06, divided by 1 minus 1 plus 0.06, all to the negative N, which is negative 20. Remember, it's 10 years and he's paying 2 times a year. So here's a little baby step. This is $20,000. Assuming babies can put all this into a calculator, they would get 0.08771845, right? Just to help you follow along with your calculator. So his payments are a mere $17,436.91. You are paying for your house in Detroit or your apartment in Manhattan. So every payment, every 6 months. And this is the answer to part A. Every 6 months. So this is the answer to part A. $17,000. $436.91. Find the total amount of each payment. Okay, find the total amount paid over the life of the loan. No problem. So the total amount paid, B, how much is he paying total? It's always kind of a sobering figure, isn't it? So the total is going to be how much is he paying each month, right? So he's paying $17,000, $436.91. That's R. And he's paying that 20 times, right? You could think of that's N, the number of payments. He's paying this every 6 months, 20 different times, and then plus the $150,000 he put down with the down payment. Do you see that? That's how much total money he is putting into this house. So that is 498,738.20. So the total amount that he has shelled out over the 10-year period is $498,738.20. Again, that's the amount he paid every 6 months times the 20 payments. So he made 20 payments of this much plus his down payment is this. And part C asks find the total interest paid over the life of the loan. Okay, so he paid this much money was the total amount that he paid, but remember the price of the house was $350,000 was basically the price or the debt that he borrowed. So the difference, let's do this, let's make a big subtraction. The difference is going to be the interest. Do you see that? This is the total amount of money that he paid was almost $500,000, but the debt was $350,000, so the rest of this is interest. So the interest is going to be 148,738.20. So that's a lot of interest. But if at the end of 10 years he can either sell this nice little apartment on 84th or this lovely house in Detroit for $500,000, I guess he made his money back. So that's how you do some of these problems, and this amortization formula is the one you're going to want to write down and use over and over for these problems.